Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson, we are going to discuss about the different data types present in the Solidity language. So first of all, we've already discussed this when we were discussing about the features of Solidity language, that it is a statically typed language. By statically typed, we mean that we need to basically define the type of data for a variable at the time of compilation itself. This means that we need to decide whether a variable is going to store an integer value or a Boolean expression or a string value or some other address type or anything right at the time of writing the code. You cannot delay this categorization of the data to a later point after the deployment of the contract. So that is only possible in dynamically typed languages, of which JavaScript is an example. But in Solidity, since it's a statically typed language, so you need to mention the data type beforehand. So here now we need to study what are the different data types available to us in this language. So in Solidity, data types can be classified into two types. One is the value types, where we have signed integers, unsigned integers, booleans, address, enumeration, and bytes. And the second type of data type, which is present in the Solidity language, is the reference type. Under reference type, we have arrays, strings, structs, and mapping. So we are going to discuss in detail about each and every type of data type which is mentioned here. So, but let me just give you a brief overview of what all this is about. So, we know in most of the programming languages, actually, these are the two categorization of data types: value types and reference types. So, I'm sure that if you have any programming language before Solidity, so this concept is same for those languages as well. So there is a value type thing. So there you basically, the values are always duplicated, and wherever you use them, the value types. And in reference type, what happens is the values which you use, they are actually, they point to an address in a memory, and so that is why you do not copy the values, but you actually pass the address. So the original value is always passed whenever we are talking about the reference types. And we will be actually understanding this practically by writing a code also. So first of all, what are the different value type data types available in Solidity language? They are in integers also. We have two types. This is new, this is very new, and this is a characteristic feature of Solidity language, that we have signed integers here, unsigned integers here. Booleans are common. Address is a specific data type specific to Solidity language. I'm sure if you haven't worked on blockchain technology before, then other programming languages do not have this data type address. Again, enumeration is a common data type which is present in other languages as well. And again, bytes is a new data type introduced in the Solidity language. So we are going to discuss about each of them in detail, and then you will understand the difference between each of them. Then again, in reference types, arrays, strings, structures, these are, I think, the common data types which we have in all the languages. But mapping is a data type, reference type data type, which is very unique with the Solidity language, and it's very useful. So we will be covering all of this one by one. So first of all, let's begin our discussion with understanding the signed integers. So, what are signed integers? First of all, signed integers are declared with the int keyword, that is the int keyword. And signed integers, as their name suggests, are used to store either positive or negative values in smart contracts. So now we know that in other languages, for example in Java, we just have an integer. So integer can mean a negative integer or zero or a positive integer. But in Solidity, we have a differentiation here. So in case you want to store negative integers or positive as well, but you know, if there is a sign which is associated with an integer, that means a negative or a positive sign, so then you can make use of this data type, which is known as the signed integer. There is also another category, unsigned integer, in which negatives are not allowed, only 0 to positive values are allowed. So then what is the difference? Because since you can write positive integers in signed also and positive integers in unsigned also, so why are we having that unsigned integers as a special category? Because of the range. What is the range? We will discuss just in a while. So for now, signed integers means that basically you can store either positive or negative values in your smart contracts using this. And what is the keyword used to store this data type? It is the int data type. Again, int is an abbreviation for int 256, and it has a range of -2 raised to the power 255 to 2 raised to the power 255 minus 1. Now this may sound a little confusing, so let me give you a background for this. First of all, signed integers are of multiple types again. So there is not just one data type which is known as int. So there are multiple data types here. There is int 8, starting from 8, and in steps of 8 up to 256 you have all the data types available, which means int 8, int 16, int 24, int 32, int 40, all of them up to int 256. All of these are allowed to be used as data types. What is the difference between all of them is the size which can be allotted to that data type. So the biggest among this, the biggest is int 256, and that is why int 256 can be replaced by int also. But in case you want to write int 8 or int 16, then you will have to write it int 8, int 16. But if you're not writing any number along with int, then by default it is considered to be int 256, because that is the largest possible size present with the signed integer data type. So now we've understood that all these are signed integers. So what is the question with the range? What is the difference between all of them? The difference is in the range, the allowed numbers. As we can understand, this is somewhere related to the size of the data which they are storing. So int 8 appears to be the smallest smallest storage occupying data type, while int 256 looks like the biggest one, and it is true. So what happens is that in int 8, you are only given 8 bits by the Solidity language, not the 8, yeah, so 8 bits. So in 8 bits, basically, how many numbers can you store? If you can give a range, so if you are from a computer science background, so you know that if you have 8 bits with you and you want to store negative and positive numbers in that, then the range of the numbers would be -2 raised to the power of 7 to 2 raised to the power 8 minus 1, which comes out to be minus. So 2 raised to the power 7 is 128. 2, yeah, 128. So minus 128 to 128 minus 1, which is 127. So that means for int 8 data type, the range available to you is -128 to 127. In case you try to save 200, number 200 in that data type, it will give you a compilation error at the time of compilation itself, because it has seen that you have used int 8 as the keyword and it can only store a limited range of numbers. Since you are overflowing with your range, so it will not be allowed. For that, you will have to increase the size of your data type to maybe int 16 or 24 or 32 or whatever. But in just in case you want to be very sure, you can simply use int, because it will be the maximum possible. It will be 256, which has a range of 2 raised to the power 255, which is a pretty big number, and most of the numbers are accommodated in that. So in case you want to be sure that there is no problem of overflow, you can use this. Obviously, the advantage of using int 8 would be you will be saving a lot on the size of the data. In case your smart contract requires you to have a number of state variables, as we've discussed in the lesson in state variables, that state variables actually require a lot of gas. So in case you want to have maximum number of state variables and that too are taking a lot of space, so then you can always optimize them by using the correct form of data type. So this all these subtypes of the int data type comes into picture there. So the size, the maximum size is 32 bytes. As you can understand that if it is 256 bits, which means 32 bytes. So if the maximum size basically of signed integer of the int keyword is 32 bytes. So again, as I told you, small sizes are also possible. So small sizes more than 32 bytes. So 32 bytes is not a very less number. So in case you want to save on some space, then small size is also possible. How is it possible? You can specify the number of bits you want to use, but that should be in steps of 8. So you cannot say int 20. That will not be allowed. Int 16, 20. Multiples of 8 are allowed. Okay. So like int 8, 16, 24, etc. So this is it for signed integers. We will be practically writing it also and viewing it for ourselves. But for now, you should know that int keyword, int 256, steps of 8, the basic size, and you should know that the default value of a signed integer is 0. Now let's discuss about the unsigned integers. Unsigned integers are similar to signed integers. The only difference is that here we can save only positive values. So they are declared with the uint keyword, and they're used to store either 0 or positive values. Again, the abbreviation is uint here. So the only difference is in the range. So you can see that here the range becomes 0 since it cannot take negative numbers, to 2 raised to the power 256 minus 1. In other case, it was 2 raised to the power 255 minus 1. So that's the difference. Size is same because 256 bits we have here also, so 32 bytes. Again, small size steps are possible if you just you have to use the steps of 8, 8, 16, 24. You can save all these numbers. So everything is same except for the range. Here the range is enhanced. So in examples where you are, for example, writing an NFT smart contract and you need to maintain a counter for maintaining the token IDs, you know that they are always going to be positive. So it's better to use unsigned integer for those kind of instances, so that there's no confusion. You cannot by mistake store in negative values, and also your range is increased, right, for that. So these are the cases where you need unsigned integers. Again, the default value for them is also 0. Moving on to our next data type, Boolean. Boolean data type is very simple data type, and it's mostly similar to other programming languages. It is declared using a bool keyword, and it is used to store binary results, which means it can store only two values, either true or false. And as you might have guessed already, the false is the default value for a Boolean keyword. So in Solidity, we have default values for everything. So for Boolean, we have it as false. The size occupied by a Boolean data type is 1 byte, and it supports standard Boolean operations like not equal to, equal to, and or. So all those operations which are supported in other languages also, Solidity also supports them. So you can use them for Boolean expressions. That's it for today's video. We have discussed signed integers, unsigned integers, and Boolean today. We'll be covering the other data types in our next video.